Right, the beginning of question 3 is a standard question about geometric series. It tells us this in the question. It tells us the first term, which in the formula we give letter A, and it tells us the common ratio, which has letter R. As soon as I see it's a sequences and series question, I turn in my formula book to the section on the series, which I've written down here. So part A just says sum to infinity. In the formula book, you have S for sum, and then the infinity symbol, and I can just copy the formula out, which is A over 1 minus R, and they've just given me the numbers in the question. So that's 54 over 1 minus 8 over 9, and I just type that into my calculator, and it tells me it's 486. Part B as well is just substitution into the formula. So this time it says the second term. Now the nth term formula is the un one, so un is arm minus 1. So the second term is a times the common ratio to the power of 2 minus 1, which is the power of 1. And again, we can just type that in and get that the answer is 48. Now, this is where we actually start to get some slightly trickier questions in the paper. We have to do a bit of thinking, which is part C. So show that the 12th term of the series can be written in this form. Well, to start with, we need to find the 12th term. So U12 is A, so that's 54, times R to the power of 12 minus 1, which is 11. And there was actually a mark for just writing that down. So even if you didn't know where else to go, let's start out with that. The brackets are important because they show that the 8 and the 9 are both to the power of 11. Now let's have a look at where we want to go. We want it in the form 2 to the power of something divided by 3 to the power of something. Well, can we write any of this as powers of 2 and 3? Well, 8. What do we know about 8? 8 is the same as 2 cubed. What do we know about 9? 9 is the same as 3 squared. And that's already started us off writing this in the format that they're looking for. Okay, what else can we do? Well, we can use our rules of indices on this term with the 2's. So we've got 2 to the power of 3 to the power of 11. So that's 2 to the 3 times 11 is 33. Oh, my multiplications become equals. Just change that. And we've got 3 squared to the power of 11. So that's 3 to the 2 times 11 is 22. We're getting close. We've got the 2's and the 3's. We've just got the 54 left. Now we need to write 54 in terms of 2 and 3. It's something you might remember from the college days about these factor trees. So how do we do that? Well, we write down 54. Is 54 divisible by 2? Yes, it is. So 54 is 2 times 27. 2 is a prime number, so we stop. Is 27 divisible by 2, because that's the lowest prime? No, it's not. Is it divisible by 3? Yes, it is. It's the same as 3 times 9. 3 is a prime number, so we stop. Is 9 divisible by 2? No, but it's divisible by 3. That's 3 times 3. 3 times 3 are both prime numbers. And this tells us that 54 is the same as 2 times 3 times 3 times 3, or 2 times 3 cubed. That means we can go back to our formula. 54 is the same as 2 times 3 cubed times 2. So that's 3 over 3 is 22. So that means then combining all our powers, we've got 2 times 2 to the 33, so that's 2 to the 34. On top of our fraction we've got 3 cubed, and on the bottom we've got 3 to the 22. So that leaves us with 3 to the 19 after we've cancelled our 3's on the bottom of the fraction. And so there it is, written in the form required. 2 and 3 and p and q are integers.